Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, students, and uh, future engineers. Here are some problems here in algebra on coordinates and graphs, particularly in computing the slopes, lengths of medians, and area of triangles, as well as the vertex angles. If you want to anticipate the solution to this problem, those who have already finished college in engineering, then you can pause the video and solve the problem. Draw the triangle having the vertices A at 4, negative 5, B, negative 2, 3, C, negative 1, 7, and A, find the lengths of the sides, B, find the slopes of the sides, and C, determine the vertex angles A, B, and C, then find the area. So for the lengths of the sides, let's plot the points first. A at 4, negative 5, B, negative 2, 3, and C, negative 1, 7. So for the length of AB is square root of. So we begin with the terminal coordinate. So negative 2 minus 4 quantity square plus 3 minus negative 5. So 3 minus negative 5 is 3 plus 5 quantity square. So it is 10 units. Length of BC is C first, square root of negative 1 minus negative 2. So negative 1 plus 2 quantity square plus 7 minus 3 quantity square. So it is square root of 17 units. Length of AC, so C first, negative 1 minus 4 quantity square plus 7 minus negative 5, so 7 plus 5 quantity square. So it is 13 units. The slope of AB, because we arranged from this distance formula, so it is just delta y, which is 3 plus 5, 8, over negative 2 minus 4, so negative 6. So that's why it is negative 4/3. Slope of BC is, this is 4, positive 4 over 1. So 4 over 1 is 4. While the slope of AC is equal to 12. This is 12 over negative 5. So negative 12 over 5. Negative quantity 12 over 5. And let's proceed to see the vertex angles A, B, and C. So first, let's have the if you want to apply the formula, then it is tangent of an angle, but remember the angle should be measured in counterclockwise direction, and the formula should be slope of the terminal side. Tangent of the angle is slope of the terminal side minus the slope of the initial side, then all over 1 plus the product of the slope. So all over 1 plus slope of the terminal side times slope of the initial side. But that is only capable of computing acute angle. In computing this obtuse angle, so in counterclockwise direction, so this should be the slope of the terminal side, the one that has slope of 4. Initial side is slope of AB, which is negative 4/3. But this cannot compute or determine the slope directly, this obtuse angle here. So instead, it is this angle here. So initial side is this in counterclockwise direction. So if we extend this rather, and in counterclockwise direction, so This is the initial, then that's the terminal in counterclockwise direction. So if we extend, this, then extend this, so it cannot compute the acute angle. So counterclockwise direction, we extend it this way, so it will be negative. So it should be 180 degrees minus the absolute value of whatever is the result. But I presented here a solution which there's no need to memorize formulas, and we can easily compute it as long as you can recall your background in trigonometry. So for instance, we have angle A. The slope of AB, we just treat them positive, everything. So 4 over 3, negative 4 over 3, but let's just make it positive. 4 over 3, negative 4 thirds originally. And that is angle A. And the slope of AC is also negative, but we just treat them as if they are right triangles and with positive sides. So 4 opposite to this angle, then 3. Therefore, the angle here, the measure of the angle here is inverse tangent of 4 over 3. You will get 53.13 degrees. Likewise, this one has slope of negative 12 over 5, but supposedly vertical is 12, horizontal is 5, will make it positive. Then we can compute this angle here. The measure of this angle here is inverse tangent of 5 opposite over 12. So you'll get 22.62 degrees. Therefore, the measure of angle A is 90 degrees because the total angle here is 90 minus 53.13 degrees minus 22.62. This is now the solution without relying on the formula that I derived. So angle A is 14.25 degrees. Then B, angle B, which is obtuse, the slope here is 4. So we can compute this directly. Inverse tangent of 4, or inverse tangent of 4 over 1, 75.96 degrees. And this, the measure of this angle here from the horizontal to this side is the same as the angle from the horizontal to this side. So 53.13 degrees also. So angle B is obtuse. It is 75.96 degrees plus 53.13 degrees. So it is 129.09 degrees. Then finally, for this angle here, the measure of this angle and that angle there from the horizontal to this side is the same, 75.96 degrees, while the measure of this angle is inverse tangent of 12 over 5 from the slopes here, from the slope of this side, or it is 90 degrees minus 22.62 degrees. So therefore, this angle C is 180 straight line angle minus 75.96 degrees minus 67.38 degrees. So if you still cannot follow the explanation and the solution, you just pause the video, then I think it's obvious here, it's clear. 180 degrees minus 75.96 degrees minus 67.38 degrees. So it is 36.66 degrees. Then you check the sum of A, B, and C angles should be 180 degrees. Then for the area, although there is a formula area by coordinates, I will not use that yet here. I'll just apply area of rectangle minus area 1. So we have this rectangle here, the dimension horizontally is 4 minus negative 2. So that's why this is 6 units. And the height is upper y 7 minus negative 5, 12 units. And for the triangles, this right triangle here, the dimension would be horizontally, it's also 6. Vertically, it's 3 minus negative 5. 3 minus negative 5 is positive 8. Then for this triangle here, negative 1 minus negative 2, so 1 unit, or you can read it from the figure right away. And 7 minus 3 is 4, so 1 by 4, area 2. Then area 3, which is this is equal to 4, right x 4 minus left x negative 1, so 5 units. That's why the total base of the rectangle is 6 units. And the height is 7 minus negative 5, so that's also 12. So area, therefore, of the triangle is area of the rectangle minus area 1 minus area 2 minus area 3. Area of rectangle is 6 by 12 minus area 1, 1 half of 6 times 8 minus area 2, 1 half of 1 times 4 minus area 3, 1 half of 5 times 12. So computing, the area is 16 square units. The other way is we apply area by from trigonometry, 1 half product of adjacent sides times sine of included angle. So it is 1 half the length of side BC, which is square root of 17 times, we apply this, and this is now the solution. So first, 1 half of AB times AC. AB is 10, AC is 13, then sine of angle A, which is 14.25 degrees. So it is 16 square units, like that. 1 half of this length, square root of 17 times AB, which is 10. So 1 half of AB, 10, BC, square root of 17 times sine of this angle, sine angle B, 129.09 degrees. So it is also 16 square units. Then 1 half of BC times AC, sine of angle C. 1 half of BC, square root of 17, 1 half of AC, 13, then sine of angle C, sine of 36.66 degrees. So it is also 16 square units. So that's it for this part. So for the continuation, another problem, a median of a triangle is a line segment from a vertex to the midpoint of the opposite side. Find the length of the medians of the triangle having vertices A2, 3, B3, negative 3, and C, negative 1, negative 1. Also find the coordinates of the centroid. Now, we already have formulas for midpoints. It's simply 1 half, or the average of the coordinates of the end points of the lines. So for these are the medians. So for median through A, this is the median through A. This point is the midpoint of BC. So the coordinates of the midpoint of BC would be 1 half negative 1 plus 3. 1 half of negative 1 plus 3 is 1 half of 2, so 1. 1 half quantity negative 1 plus negative 3, 1 half of negative 4 is negative 2. For the median through B, which is this is 1 half of 2 plus negative 1, so 1 half. 1 half of 3 plus negative 1, so it is 1. Then for median through vertex C, which is this, 1 half of 2 plus 3 is 5 halves. Then 1 half of 3 plus negative 3, 1 half of 0 is 0. So for the length of median through vertex A, which is this, by Bissad's formula, it is square root of, this is the terminal side, so square root of quantity 1 minus 2 quantity squared plus quantity negative 2 minus 3, so negative 5 quantity squared. So the median is square root of 26 units. For the median through vertex B, so this is the terminal, so 1/2 of quantity 1/2, uh, sorry, square root of quantity 1/2 minus 3 square, 1/2 minus 3 quantity square, plus quantity 1 minus negative 3, so 1 plus 3 quantity square. And that it is square root of 89 over 2 units, because your calculator aided. Then the median through C, 1/2 of quantity, sorry, distance formula, square root of quantity 5/2 minus negative 1, so 5/2 plus 1 quantity square, plus 0 minus negative 1, so 0 plus 1 quantity square, and it is equal to square root of 53 over 2 units. So that's the median through C. Next is the coordinates of the centroid. So also find the coordinates of the centroid. Since the centroid is defined, although we I derived the formula for the centroid as 1/3 of quantity x1 plus x2 plus x3, or 1/3 of quantity xa plus xb plus xc, and 1/3 of quantity ya plus yb plus y sub c. So that's the core formula for the centroid of triangles. Only triangle will have that formula. So if it is a quadrilateral, divide the quadrilateral into triangles, then you can find the centroid of the individual triangles. So this is derived in my, if not in Vitamath, maybe it's also here in Engineers in Progress. So the idea is the centroid is 2/3 of the length along the length of the median from the initial point. So that means this is 2/3 of the length of that median through A. So if it is 2/3 of the entire median through A, then that means from point A to the centroid of the triangle, it is 2 parts. And from the centroid to that other point, it's 1 part. So that 2 divided by quantity 2 plus 1 is 2/3. That's why I'll just call that 2 parts. Then by similar triangles, because this is a straight line, then we have xg, the terminal coordinate of x at the centroid, minus 2 as to 2 units is equal to 1, this one, the other endpoint of the median, minus 2 as to 3 units, which is the hypotenuse. Supposedly, we are defining sine of the angle or cosine of the angle it makes with the x-axis. So we imagine a right triangle, vertical and horizontal, and the angle here that this median makes with horizontal is theta. Then you can define cosine of theta. But this is just proportion or similar triangles. So xg minus 2, which is the horizontal projection of this AG, line segment AG, as to 2. So horizontal as to hypotenuse equals horizontal of this other endpoint to A. So the whole median, 1 minus 2, then as to the hypotenuse, which is 3 units. So solving for xg, x sub g is, this is negative cross multiply, so negative 2/3, then plus 2. So xg is 4/3. Likewise, for the y, yg minus 3 as to 2 is equal to negative 2 minus 3 as to 3 units, the hypotenuse, or define sine of the angle theta. And you will get cross multiply 2 times negative 6 negative 5, so negative 10 over 3, then plus 3 transpose. So you'll get negative 1/3 for YG. So the centroid, therefore, of the triangle is at 4/3, comma, negative 1/3. Then the direct formula, this is the direct formula. So G is 1/3 of quantity A, X coordinate of A2, plus negative 1, or plus B, sorry, plus XB3, plus X sub C, negative 1. So that's 5 minus 1, 4, 4/3. This is that. Then 1/3 of 3 plus negative 3, that's 0, plus negative 1, so negative 1 over 3, so negative 1/3. So that's it for this video.